Ryōiki Tenkai. The domain and range of a radical function. We have here a function which contains a radical expression. We have f of x is equal to the square root, or specifically the positive square root of 3x minus 1. We are going to show here the domain and the range of this function together with the processes which involves in getting them. Let's start with the domain. But first, let's try to write this function in terms of y, since we could have y as the representative of f of x. So this is still square root of 3x minus 1. For the domain, it is the set of all possible values of x that can be substituted here and will still result to a real number for our y. Now, if we're going to look at this, since this is a radical expression, there are now restrictions. The restrictions is that the radicand, which is the entire binomial expression here, should not be negative. Because if you have a square root of a negative number, it becomes an imaginary number, hence not part of the real numbers. So that's just the hint that we are going to use now. We are going to take the entire radicand expression, 3x minus 1, and this should not be negative. Hence, it should not be less than 0. But we can accept 0. It would be greater than or equal to 0. This means all possible values for the binomial expression that is either 0 or positive. It also includes fractions and decimal notation as long as they are all positive. Okay? In this case, we are going to use this linear inequality in solving for the possible values of x. So we simply add both sides by 1, add 1 here. So you will have 3x is greater than or equal to positive 1. Then, dividing both sides by 3, we will get here a result for linear inequality values of x, because this becomes 1, is greater than or equal to positive 1/3. These are now the possible values of x that can be substituted in our given equation or function. Let's try the smallest possible value because it's greater than or equal to 1/3. In short, the smallest possible value is positive 1/3. If 1/3 is substituted here, that's 3 times 1/3 is 1. 1 minus 1, 0. The square root of 0 is still a real number, which is 0. Imagine a value less than 1/3. Let's say 0, because 0 is less than 1/3. 3 times 0 is 0. 0 minus 1 is negative 1. Hence, the square root of negative 1 is imaginary. So this is the smallest possible value for x. But we could again include other values greater than this. Let's say 1. 3 times 1 is 3 minus 1, 2. Square root of 2 is a real number. If this is 10, 3 times 10 is 30 minus 1, that's 29. Square root of 29 is also a real number. This now tells us the domain, because the domain allows us to make a set of all possible values of x, and these are the possible values of x. So we simply have here the set builder form. So we have x such that x is greater than or equal to 1/3. This is now our domain. We include here all possible values of x starting from 1/3 and going up. Now let's proceed with the range. The strategy that we did in solving for the range of a linear function was to come up with an equation where we are going to solve the value of x in terms of y. But since here this is a radical function, we have a specific method which is easier to be used. We simply need to use the smallest possible value on our domain and use that to get the smallest possible value of our range. So we still have here this range, this equation, y is equal to square root of 3x minus 1. We don't need to solve for x in terms of y here. You simply pick the smallest spot because we have restrictions, right? If we have restrictions, we simply use those restrictions or the least possible value that is possible. Okay, so we're going to use here 1/3 because it includes 1/3. If we're going to substitute 1/3 here, we will have y is equal to, as mentioned earlier, 3 times 1/3. Then you minus it with 1. We have y is equal to square root of, that's 1 because that's 3 divided by 3 is 1, minus 1. So y is equal to the square root of 0, which means that y is equal to 0. This is the smallest possible value for our range. It's not just 0. Take note that for our domain, it's not just 1/3. It's all possible values of x that is greater than or equal to 1/3. In this case, 0 for y is not only the member of the range, but we are going to have it here, y as greater than or equal to 0. Hence, our range is a set of y such that y is greater than or equal to 0. By the way, for our range, which involves positive square root of a radical function, we have this as our range all the time. Take note, again, it's greater than 0 because if you're going to substitute here, let's say 1, yes, 1 is possible for the range, our domain. 3 times 1 is 3 minus 1, that's 2. So it's possible to be used. And then it's part of our range as well. Now, to move further, we could also use the idea of this Cartesian plane. Let us try to graph the representative graph of this function, and let's use that graph in analyzing whether our answers for domain and range are correct. So we simply need to pick the possible values of our x, which will give us the possible values of y for our point. And since this is a radical function, we just don't need 2 points because 2 points determine a line. That's for linear function, but here we might need 3 or 4. So we have 1/3. This is the first pair, 1/3 and 0. So 1/3 is somewhere here. So it's very small, so pardon with me. So we have, if this is 1/3 somewhere here, and 0. This is our starting point now. Now let's try to pick other values of our x here, or our domain. What if x is equal to, let's say, a certain 2/3? Okay, what if it's 2/3? When we substitute 2/3 here, take note that's 3 times 2/3, or it becomes 6/3, that's 2. Minus 1 is 1. Square root of 1, 1. So we have y is equal to 1. So 2/3 is just beside this, and we have here 1 for our y. Let's have another point. X is equal to a certain value. Let's try to use certain values that will come up with what do you call this one? Integral values, so we can plot them properly for our y. Let's say 5/3. If x is 5/3, that's 15/3 or 5 minus 1, it's 4. So square root of 4, we have here 2. Take note that 5/3 is 1 and 2/3, so it's somewhere here, and 2 is somewhere here. Okay. Let's have the last point. Can we choose other point that is possible here? Let's say a certain 10/3. I'm using fractions. Okay, don't worry about that. 10/3 times 3 is 30/3, that's 10. Minus 1 is 9. Square root of 9, we have here 3. So 10/3 is a 3 and 1/3. So 1, 2, 3, 1/3 here. And we have 3 somewhere here. Okay. Pardon if my graph is not that accurate. 1, 2, 3. Hopefully we can still show here a representative graph connecting these points. Hopefully I could connect them properly. You have something like that. Sorry, it should be like that, and so on and so forth. Or it will little bit steeper, but the graph will look like this. Take note that our horizontal axis is x, our vertical axis is y here. Now with this graph, if it's the graph that is given, you can also deduce the domain and range. Take note that the domain are all possible values of x pertaining to the horizontal movement. But when you look at the horizontal movement, you don't include these points here. We don't have points somewhere here, right? The points for our graph started here, and the value for this is 1/3, okay? And when you move towards your right, there are no breaks on the graph. There are representative values for our y-axis, and as this goes further on, our value of x still goes further on. Hence, our domain earlier, which accepts all possible values of x such that x is greater than or equal to 1/3, is correct. Now look at our y, the vertical movement. We don't have points somewhere here, which includes the negative values of our y. Our graph started at this point, which is for y equals 0. And when the x values are increased towards positive infinity, the y also increases upward. It may not look like here, but as you move further, let's say 1,000, 1,000,000, the graph for y will still increase upward. This connects to the point that our range starts from 0, the value of y, and it goes upward. Hence, our range is also correct. So this is how we determine the domain and range of a radical function, and these are the processes that will help us analyze using a graph. For the next functions, please do not forget to like this video, share this, comment down, and subscribe to our channel. This is for us to expand our domain further.